Every second, your body is getting older, even right now. But the real question is this an inevitable sentence or a process we can hack? In this video, we'll break down why humans age, what happens inside our cells, and whether it's truly possible to stop aging, not just by a cream labeled anti-age. And at the end, there will be the main conclusion. Maybe we've been fighting the wrong enemy our whole lives. Block 1. Aging begins. Sooner than it seems. When we talk about aging, most people imagine wrinkles, gray hair, and weakness. But that's only the visible part of the iceberg. Real aging begins deeper. In the cells, in DNA, in energy production, in the immune system, and even in the way the body reads its own instructions. You may look perfectly fine, but inside, your body is already starting to lose small battles. Around the age of 25 to 30, some repair systems gradually begin to slow down. Not suddenly, almost invisibly. Before, you could stay up all night and feel alive in the morning. Later, you stay up all night, and it feels like you've been hit by a truck. That is the first signal. The body still works, but the cost of recovery becomes higher. But why does this happen? Why does an organism that can create a human being from a single cell later begin to break down? Imagine the body as a huge city. Billions of citizens are cells. Roads are blood vessels. Power plants are mitochondria. The archive of laws is DNA. Aging is not one explosion. It's when small accidents accumulate in the city for years, until one day the system can no longer cope. Block 2. Main cause number 1. DNA damage. The first suspect is DNA. It is the instruction manual by which every cell operates. Every day, DNA is damaged by sunlight, toxins, inflammation, and simply by errors during cell division. Fortunately, the body has repair crews. They constantly fix the damage. But with age, there is more damage, while the repair systems work worse. And if an error hits an important place, the cell may work incorrectly, stop dividing, or become dangerous. This is how tiny molecular scratches eventually turn into major problems for the body. Block 3. Telomeres, the protective caps of chromosomes. The second suspect is telomeres. They are often called the biological clocks of the cell. Telomeres are the protective tips of chromosomes, like the plastic ends on shoelaces that keep them from fraying. Each time a cell divides, telomeres usually become a little shorter. When they become too short, the cell receives a signal. Enough. You can't divide anymore. And this isn't just bad. It's protection against cancer. The body would rather stop a suspicious cell than allow it to divide endlessly. Here is the first big dilemma of aging. Everything that extends a cell's life may have a downside. Block 4. Senescent cells, the zombies within us. The third suspect sounds almost like something from a horror movie. Senescent cells, or zombie cells. They no longer perform normal work, but they don't disappear either. They sit in tissues and release inflammatory signals. In a young body, the immune system quickly removes these cells. But with age, the cleanup becomes worse. And then zombie cells begin to poison their neighbors. Not instantly, but constantly. They are linked to chronic inflammation, declining tissue function, and age-related diseases. And here's where it gets really interesting. Scientists are already trying to remove such cells, and in animals, this sometimes improves health. Block 5. Mitochondria, power plants that emit smoke. The fourth suspect is mitochondria. They are the power plants of our cells. They turn food and oxygen into energy, allowing the heart to beat, the brain to work, and muscles to contract. But over time, these power plants become less efficient and produce more smoke, free radicals. Free radicals can damage proteins, membranes, and DNA. This is called oxidative stress. But here's the paradox. Mild stress, such as exercise, doesn't destroy the body. It trains its defenses. The body doesn't love comfort as much as it loves the right challenges. Too much stress destroys, but moderate stress makes the system stronger. Block 6. Protein waste and loss of quality. The fifth suspect is protein waste. Our cells constantly produce proteins like a factory producing parts. But proteins must be folded correctly. If their shape is damaged, they can clump together and interfere with the cell's work. In youth, the cell cleans up waste well. It has recycling systems, for example, autophagy. With age, cleanup becomes worse. Waste accumulates and the cell begins to suffocate in its own garbage. This is especially frightening for the brain. Neurons live a long time and tolerate accumulated damage poorly. So aging is not just wrinkles. It is also a problem of cleaning, repair, and quality control. Block 7. Epigenetics. The organism forgets what it is supposed to be. The sixth suspect is epigenetics. This may be one of the most fascinating mechanisms of aging. If DNA is a recipe book, then epigenetics is the bookmarks, which pages to read and which to ignore. A young cell knows very well who it is: a skin cell, muscle cell, liver cell, or brain cell. But with age, these marks become disrupted. The cell begins to understand its role less clearly. It's like a library where the books are no longer in the right places. The information exists, but access to it is broken. And here comes an almost science fiction idea. If epigenetic marks can be reset, can we rejuvenate a cell? Module 8. Stem cells and regeneration. The seventh suspect is stem cell exhaustion. Stem cells are the body's repair reserve. They help renew blood, skin, muscles, and other tissues. But with age, this reserve becomes weaker. Repairs happen more slowly. That's why in childhood a scratch disappears almost magically, while in old age recovery can take much longer. Muscles lose mass, skin loses elasticity, and the immune system loses speed. And now the puzzle comes together. Aging is not one mechanism. It is a network of failures that amplify one another. Block 9. Climax. Can aging be stopped? And here is the main question. Can all of this be stopped? The short, honest answer. Today, we cannot completely stop human aging. But that doesn't mean we are powerless. In laboratories, scientists are already studying senolytics, epigenetic reprogramming, gene technologies, and regenerative medicine. In animals, some approaches really do extend healthy lifespan. But transferring this to humans is difficult and risky. The problem is that interfering with aging means interfering with the body's fundamental settings. For example, making cells divide more actively sounds like rejuvenation, but uncontrolled division is already a path toward cancer. So, if someone promises to stop aging in 30 days, they are probably only stopping the movement of money in your wallet. But there are things that already truly influence the speed of aging, not magically, but through biology. And now comes the most useful part of the video: what you can do today to extend not just life, but functional youth. Block 10. What really slows down? Aging. First, movement. If physical activity could be packaged into a pill, it would be one of the most powerful anti-aging drugs. Exercise improves mitochondrial function, insulin sensitivity, blood vessels, the brain, and reduces chronic inflammation. Muscles are especially important. Muscles are not just about appearance. They are an organ of longevity, a metabolic shield. Sometimes an active 70-year-old is functionally younger than a sedentary 40-year-old. Second, sleep. During sleep, the brain and body do not shut down. They repair themselves. During sleep, the brain more actively clears metabolic waste, hormones return to balance, and the immune system reorganizes. Chronic sleep deprivation is an accelerator of aging. More inflammation, worse memory, and a higher risk of metabolic problems. Third, nutrition. Not a magical diet, but a stable system. Enough protein, fiber, micronutrients, and minimal ultra-processed food. Excess sugar, overeating, and constant energy spikes can increase inflammation and metabolic wear. But it's important. You don't need to turn food into a religion. Longevity loves consistency, not fanaticism. Fourth, light, fresh air, and routine. Our cells live according to internal clocks. When day and night get mixed up, the body manages hormones, recovery, and metabolism worse. Fifth, stress. Short-term stress trains. Chronic stress wears the body down. If the body lives for years in threat mode, it repairs itself worse and becomes inflamed more often. Sixth, social connection. It may not sound as scientific as telomeres, but loneliness is linked to poorer health and higher mortality. The brain and body need meaning, movement, connection, and novelty. It's not only the body that ages, lifestyle ages too. The main idea: we cannot cancel age, but we can manage the systems that determine how exactly we age. Block 11. The future of anti-aging. Now let's look into the future. What if aging is one day treated as a disease? AI, genetics, biomarkers, personalized medicine. All of this may change the way we approach aging. Even now, people talk not only about chronological age, but biological age. How old your body is based on the condition of its systems. In the future, we may be able to measure aging more precisely and intervene earlier, before diseases appear. But it's important to remember, many methods are still in research. Not everything that sounds like the future is already safe today. The real revolution will not be about living to 150 in weakness. It will be about making 80 feel like an active 50. The finale, the main conclusion. So, why do humans age? Because the body accumulates damage for years, loses quality control, repairs itself worse, and becomes weaker at maintaining balance. Can this be stopped? Completely? Not yet. but we can slow the path toward weakness and win the most valuable thing: years of clarity, energy, and freedom. The biggest mistake is thinking that aging begins in old age. It begins today, and what you will be like in 30 years is partly decided right now.